All right, welcome back. This is Mr. Mays. Today we're going to be talking a little bit about sampling methods. And I'm so excited to be coming to you digitally through this wondrous platform. So we're going to be looking today about sampling methods, and we're also going to be looking a little bit at biases, which we've gone over in class. So this should all make good sense. But let's just roll through some of the things we learned about in class regarding these beautiful concepts. A few things that should spring to mind. First of all, we have the idea of having a sample. And that sample is always a small bit of some greater population, right? The population is whatever thing you are trying to study, right? That you want to understand on a deeper level. That's what a population is. On the other hand, the sample is the small bit of that thing that you're studying that you are actually able to do tests on and make inferences based off of, right? So the big key here is the population is the group you theorize about, right? They're the group of interest. On the other hand, your sample is the actual group you study. And the important thing to recognize here is that we use and we call it explanatory or exploratory analysis, I should say, which is basically our analysis of the sample to make inferences about the population. And that should make good sense, right? The idea is basically if I want to know, the sleep habits of honey badgers, my population would be honey badgers, and then I would measure a small sample of honey badgers and see their sleep methods. And then that exploratory analysis would lead me to recognize, here's some inferences maybe I can make about all honey badgers, right? So that's all good, wonderful, lovely. The key here, and these are the two words we will use over and over, is that we want our samples always, always, always to be representative. So again, if I'm studying honey badgers, I better be getting honey badgers of all ages, sizes, breeds, etc. if I want to say it about all honey badgers, right? So it has to be representative of the population. That's super key. And we want to be able to estimate what we call the true parameter. The true parameter. And a parameter is just an important metric. In class, I clarified that often the parameter we're looking for is like the mean value of something or the median. Sometimes it's the range if we want to look at a bunch of values and see if they range a far distance, right? It's whatever metric we're looking at that is important for the hypothesis we've formulated, right? We also need, and this is so important, alongside it being representative, our samples need to be always, always random. And we talked about a few examples of non-random samples and the problems they cause, right? So some non-random samples that are horrible because they are non-random. And mind you, random does not mean happenstance. It does not mean you run into people. Often people think that random would be something like voluntary response. So, for example, when people call in on a radio show, that would be an example. And it turns out that's not random, guys, and you know that it's not random because the only people who call in on a radio show are people who are huge fans of that radio show or who care enough to get on a phone and actually dial a radio show's number. That feels so alien to me. I feel like most people are on TikTok or Instagram. We're not calling radio shows, okay? So that's why voluntary response bias is a kind of bias. And it's not random. It seems random when you say like, oh, wow, that's random, right? But it's not random in terms of actual sampling. Another thing that's not random is convenience sampling, which is when you just interview or sample those who are closest or easiest to sample. And again, that might seem random to you, but no. There is nothing random about that at all. Convenience sampling is determinately non-random in the worst way, right? Because you're only going to interview people you are comfortable going up to, and you're interviewing people who are easy to go up to, which means they're probably people who are not avoidant of you, who are going to answer your questions, who are willing to be acquiescent, and that messes with your data. That gives you inaccurate scoops in the giant pot of soup that is your population. You want it to be representative, and non-random ruins that concept, right? And in the vein of recognizing things that ruin our beautiful random samples, let's talk about biases. We talked about a bunch of biases in class, and keep in mind, you don't need to name biases. You just need to know the idea behind certain biases and be ready to name when they might occur, right? But you don't have to name them like, this is called this, right? There are two big ones that we're gonna talk about, two like overarching categories. And category one is selection, also known as sampling bias. Now, what is selection or sampling bias? Well, selection or sampling bias is when the sample does not accurately, and this is in the slides as well, represent the population. Now, what are examples of this, you might ask? Oh, well, I got you covered. Look, voluntary response bias is a kind of selection or sampling bias, okay? Always. Why? Well, because we're just letting whoever wants to come on. No good. We have some others too. I'll call this example 2. Undercoverage bias. Now again, you don't have to name it by name, but you should understand this idea, basically, that if some members are not adequately represented in your sample, that would be considered undercoverage bias. Again, let's say I'm like, I'm gonna interview all the grannies in the neighborhood. I wanna know what all the grannies in the neighborhood think about my chocolate chip cookies. And then I only go to the grannies that live within 2 minutes of me, right? 1, that's probably a convenience bias as well. But 2, what if the grannies nearest to me know me better? And so they're more willing to give me really kind words about my cookies. But I don't go to the grannies that live in other neighborhoods that are probably more unbiased. And so because of that, I am not getting an actual representative sample. I'm undercovering the granny market on my cookie quest. Let me show you the cookie that I made. Oh, these are my chunky cookies. Yummy. Okay, another way to think about it, though, is, and this is a more serious topic, right? Like if you were looking at samples of populations and you wanted to understand how people feel about a new policy, what if you only interview people in the predominantly white side of town, right? So an undercoverage bias thing can have to do with ethnicity as well, and race. Socioeconomic status, right? Only interviewing rich people instead of poor people, things like that. Or people who are impoverished, I should say, in various levels of wealth. And this can also happen with things like gender, where you only interview men or only interview women. So yeah, those are some examples of undercoverage bias. The final one I want to talk about really quickly is non-response bias. And this will happen all the time. You really can't avoid non-response bias. Some people won't answer. It's just a fact, right? Now the key for this one, and we'll go over this later, is something known as the law of large numbers, which just states get more in your sample, if you will. If you were in class, you saw me jumping on the table saying this. The more people you sample, the lower your issues become for these other kinds of bias. Now, keep in mind, non-response bias, nothing will eliminate non-response bias. You could survey hundreds of thousands of people, and you're still going to get tons of people who don't respond. But what it can do is it can help you with things like selection bias, sampling bias, and undercoverage bias. You can keep adequately sampling. But non-response bias is something we just live with, right? So you got to go for larger numbers, but still you're always going to have people who don't answer. Okay, and that should make sense. The other type of bias, and this is going back to the overarching kinds of bias, let's look at number 2. We talked about selection and sampling bias. Number 2 is what's called response bias. And what does that mean, you might ask? Well, it just has to do with, issues from the way the questions are presented or worded. So in this case, it's not having to do with who we give the questions to. It's having to do with the questions we are giving. And the 3 main examples I showed in class were leading question bias, social desirability bias, and the halo effect. Now, if you're on the slideshow, you may recognize on slide 15, that was where in class I gave this survey, right? And on this survey, I was very simple. I said, hey, everybody, right? Is the Statue of Liberty, how tall is the Statue of Liberty? But with some people, I said, is it greater than 150 feet? And with some people, I also asked the question of, is it greater than 700 feet? And just by having this spare question, either version 1 or version 2 available, that was a form of leading question bias, because it turned out that if the 700-foot question, I think it was actually 750 feet. There was a typo here on my slides. I think it was actually 750 feet. If the 750 feet question was present with the question of how tall the Statue of Liberty was, we got a much higher median height than if the 150-foot question was present there. Because what that does is it offers parameters for your people taking your survey to think around, right? They're like, oh, it's probably close to 150 feet or closer to 150 feet versus, oh, it's probably close to 700 feet or closer to 700 feet. So that's a form of leading question bias. You'll see moving forward on slide 16, we give those medians. And on slide 17, I give you examples of political questions where the Democratic candidate is offered a bad option, right? It's like great, good, okay, and poor, versus the Republican candidate is only offered great, good, and okay, right? So if you only offer, for example, this is all for leading question bias, only offer good answers, good options, right? Good options, or only offer bad options. Those are forms of leading question bias. The halo effect, of course, you'll see on slide 19. You know that these are all AI generated, right? But the halo effect simply states that we all bring biases and stories to the table. It's a cognitive bias. And in class, we realized everyone brings certain biases to the table, whether they are bigoted biases or attempts at not being bigoted. All the same, the way we formulate questions encourages people to act on that bias. So that's something we watch out for. And then, of course, you'll see the social desirability bias. Oh, typo. Mr. Mays works on spelling. Desirability bias. And you'll see on slide 20 that we have a situation there where men lie about their height and say they're taller, right? And they do this because, of course, it is considered socially desirable to be taller, so men lie in the direction of the desirability. And one thing I want you to note is with bias, you need to say how it will affect your results. This is super important, right? So with the men part, I might be like, oh, men will lie about their height. This will lead to ooh, goodness, to larger height values in the data than are accurate. Right? Being able to say, well, this is how it'll impact the data, that's the most important part of working with biases. Right? Because sometimes it'll lead to lower values, and you need to be able to state that when you answer these types of questions. Excuse me, okay. And you can see on slide 21, I talk about the availability bias. The big one is often, the one here is about gang violence, but often the big one that we do with availability bias is that most people, it's like 70 some odd percent of people in the United States think that terrorism is a big issue, but of course you're more likely to get killed by like getting hit on the head by a coconut and such things. Okay, we have some extra questions, and we talk about random sampling. It's really important. Once again, I will clarify this. We want our samples to be representative and random. And we want a large sample size. Rah, rah. Random sampling does a great job of eliminating voluntary response bias and undercoverage bias. But of course, not non-response bias. Oh, goodness me. Non-response bias is still going to be an issue. That's okay. And same thing with like leading question and social desirability bias. A lot of these sort of these issues that have to do with these guys with response biases, that can't be fixed just by how we randomly sample, right? Because those are our questions we wrote. But we can fix a lot of these selection bias stuff with that. Okay, big thing to keep in mind, and these will be all through the slides so you can take a look at them, but I will just really briefly, and you should go through the slides for this. It starts on slide 25. I'll just quickly go through and we'll say simple random sampling. And simple random sampling, it's there. Everyone has an equal chance of being picked. Subjects are chosen independently. Oh, goodness me. And all samples are equally likely. Ooh, I'll just write equally. How about that? Instead of trying to write an equal sign, equally likely. Right? Any combination is equally likely. And if you turn to slide 26, you see I have this beautiful sketch of 9 people, and I randomly pick 3, 6, and 7, and that's my simple random sample, for example. And I give you directions on how to do this on the calculator. You will press math. Then you will do PRB, which is 3 arrows over. You'll go to RADINT, or RANDINT, I should say, which stands for random integer. PRB stands for probability. And then you will just do lower number, which is almost always 1. And then upper, which is whatever the highest value is you want in your sample. And then number of random values, which is however many things you want sampled. And you'll click enter, and it will generate those numbers randomly for you. I also go over how to do sampling from a random number table. We hate those, but for example, let's say 5, 7, 8, 2, 1, 8, 8, 9, 0, 3. And let's say I was doing 1 through 30. This was the example I gave in class. The first thing you do is note the number of digits of your upper end. In this case, it's 2, okay? So that means every 2 numbers on my random table, I'm going to put a line. And what I do is I go through and I look at every number. 57. 57 is not between 1 and 30, so it is not going to count. 82, also not between 1 and 30. But 18 on the other hand, is between 1 and 30. So that will be my first random number. And then you just keep on going, right? 89 is not, but 3, lo and behold, is. And that'll be my second random number. And you just keep going about this process. If instead of 30 it was 300, then there would be every 3 numbers. And every 3 numbers I would do my line. And so on and so forth. And that's how you do it. Okay, so now we know how to do a simple random sample on the calculator, etc. And we understand what it is. Sliding over to slide number 28, you will note we are talking about systematic. Random sampling. And that is just known as every nth person. So if you then go and take a look, I basically just say, hey, you pick a number. Let's say I pick 3. Then for every person, I'm just going to make these circles into people, right? I go 1, 2, 3, I'm going to sample you. 1, 2, 3, I'm going to sample you. 1, 2, 3, I'm going to sample you. And you do it and so on and so forth. So this would be every 3rd person for n. But you could do it with any old number you wish, okay? And on slide 29, I show you me doing that with these houses I drew, because I'm an artist. Okay, the next one is stratified random sample. And stratified random sampling is when we work with groups with commonalities. And often these commonalities are things like socioeconomic status, gender, right, race, ethnicity, some quality that we want to study. And so what we do is we separate our population into a sample, and that sample will be made up of what are called strata. These strata are the different groups, right? Whatever it is that we're interested in studying. So let's say I'm looking at, housing projects, and I want to see how it's impacting people of different socioeconomic statuses. I will split up the different socioeconomic statuses, at which point I will then simple random sample each substrata, right? So simple random sample, the low income, the middle income, and the high income. And you can do that with any of your strata, whether it's income level or age is commonly used. Like I said, gender, all of these things are common versions of stratified random sampling. Beautifully done all. Okay, and moving ever forward, we are left with basically our second to last one, which is cluster random sample. Cluster random sampling is similar to stratified random sampling, but instead of us sampling based on the qualities of our people, it's often groups based on space or time. Damn, I sound like Star Trek right now. So the example I gave at school and the version that I have on slide 31 for you would be A versus B versus C lunch. So you'll notice that the kids that go to those are all different, but they're all from vastly different economic backgrounds, gender, society. We're really not grouping people based on any of their particular qualities. We're grouping it based on the space known as the lunchroom and what it looks like during the A lunch part of the day, which is impacted by the time of day it is, as well as the kinds of kids who are allowed to go to lunch at that time. And then we look at the B hour of the day, and then we look at the C hour of the day, okay? That's cluster random sampling. Often has to do with geography too, right? Looking at people of different states, we would do that. And then once we've split them up based on, right, the city they're in, or the house they live in, or in this case, the lunchroom hour they go to, we often do it also for buses. I think the example I gave in class was the train. You look at the people at the train in the morning, in the afternoon, and then the evening. And then after that, you do a simple random sample of each of those subgroups, those subclusters, if you will. And then the final version of sampling we'll look at is just called multi-stage random sampling. And that's just if you combine stratified and cluster, right? So let's say I am looking at New York City and I want to know, I want to know where people think the best pizza is, right? What I might do is I might start by using cluster and splitting it up into the boroughs of New York, right? The categories of city, the different parts of the city. And then those boroughs I might separate based on socioeconomic status or gender or something like that, right? And you could do it the other way around. And then you can also involve systematic random sampling, right? You could do stratified and then systematic, or you could do systematic and clustered, right? And the idea here is just recognizing that you could involve two of these methodologies, and that will just get more specific results. I then have a bunch of questions that you can practice with, going through till slide 35. And I just want to remind you of one last thing known as sampling error. Remember that because every sample is random, samples will vary slightly. And we'll talk about that in more detail as the unit goes on. But the thing to be aware of here is that it's okay that samples will vary, and you cannot really get rid of that. You definitely can't get rid of that with bigger sample size, right? Bigger sample size. Oh, goodness me. Fixes everything, it seems, right? A little bit, and not entirely fixes, but is good for everything except, very important, except for sampling error. Because no matter how detailed or large your sample is, it will vary from sample to sample. You can limit it, right? You can limit it. We can always reduce sampling error. But never eliminate it. Right? It's like a sense of self or an ego. You can never truly drain it, right? So sampling error just means the error, the amount of difference in values between different possible samples we take. Even if they're very close, it will always happen, right? Now remember your bias project and recognize that today we've learned about sampling error. We've learned that we can reduce it but never eliminate it. We've learned about the law of large numbers and that making bigger samples is always a good thing for our data and reliability. We've learned about multi-stage random sample, which is where you take multiple other versions of random sampling and we combine them together to get more detailed data. We've learned about cluster, which is more about geography and space and time and how we split people up based on that. We learned about stratified, which is where we group people based on common qualities, right? Like socioeconomic status, gender, race, ethnicity, things of this nature. We've also learned about systematic random sampling, aka every nth person, where we group people, and this often happens, I will add, when we don't have a list. Right? We don't have a list of people, so we just pick every nth person. And on the other hand, that's why we have simple random sampling, is if we do have a list, we can just assign numbers to every person on that list randomly, and then we randomly select digits from a method. We learned how to use a calculator to do that, as well as a random number table. We then also learned about having representative and random samples, and to again have large sample sizes, please, my legends, please, okay? And we've learned about the problems with voluntary response bias and voluntary selection bias and undercoverage bias. We've also learned about non-response bias, which will always come with the territory, but we can limit these or eliminate them using representative and random samples. We've learned that biases are these things that often occur that can mess with the way we understand the world and understand our data. Things like the halo effect, things like social desirability bias, where people lie about qualities about themselves because they want to be perceived as good. Excuse me. And then, of course, response biases, or biases where we have issues in the way we phrase our questions. And, of course, the leading question and social desirability bias being subcomponents of that. We also then learned about different kinds of selection bias where we pick people in wrong ways. But luckily, we came up with those selection methods we went over with down below, the random sampling methods, to avoid this kind of bias. Finally, we talked about the problems with voluntary response biases and convenient sampling. And we admitted to ourselves that we will estimate the right parameter, whether it's the mean or the median that we need, sometimes the range, sometimes something wild, but always, probably always, the mean and the median show up. We want to keep our samples random. We want to form inferences using our sample to divine things about our greater population. You have been heroes. Thank you for following me through the beautiful forest, following me through the beautiful forest, yes, of sampling methods and biases. You are heroes and legends. I adore you. Let me know if you have any questions. This is Mr. Mays signing off.